This next section, I'm asked to find z-scores in the given situation. So when I do this, what I'm really doing is using a different z formula, where z equals the mean of the sample minus the mean of the sampling distribution over the standard deviation of the sampling distribution. Really, in practice, everything looks exactly the same. The only difference is that when we plug in the given mean and the given sample mean, what we're really dividing by is sigma over root n over just sigma. So it's your choice. Either you can try and do everything at once, or you can figure out what sigma over root n is first before dividing by it. I would say that rounding sometimes can be an issue, so if your calculator lets you put everything in at once, that's probably better as far as matching what you're going to get in Cengage. So if I try and do everything at once, my z equals this same mean goes here, my x bar goes first, and then I subtract that same mean. I put the original standard deviation on bottom and divide it by the root of n, or 36 in this case. When you're putting this in your calculator, make sure you got parentheses around the top. You shouldn't have to have parentheses around the bottom, but it can't hurt. If I put all that in, my calculator tells me that 198 minus 200 divided by 48 over the root of 36 gives me a z-score of negative 0.25. If I do the same math for the second problem, again, I set up z equals. I start with the given x bar, the sample mean, 16. I subtract from that the mean of the sampling distribution, which is the same as the original mean, 15. When I go to do sigma over the root of n, here I see that there's a slight trick. The reason that I present it this way is because they do the same thing in Cengage. Basically here, they've given me sigma squared instead of sigma. Because they've given me sigma squared, I have to square root it to get back to the standard deviation. So sigma equals the root of 25, which just equals 5. It's probably better if you solve for sigma up front and then put it in the formula, but I could do this all as one if I wanted to. Finishing out the calculation, sigma, 5 on bottom, gets divided by the root of n, in this case 45. When I put this into my calculator, 16 minus 15 divided by 5 over the root of 45, I get a z-score of 1.34.